Have you ever looked at a mountain of data and wondered how anyone makes sense of it all? Well, today we're going to pull back the curtain on how data scientists and financial pros connect the dots. We're going to see how a seriously powerful coding tool can help us demystify the super complex world of finance, turning abstract ideas into something you can actually see and understand.
Okay, just look at this chart for a second. This tells a pretty incredible story. For a long time, if you were doing data analysis, you were probably using tools like MATLAB or Stata. They were the standard. But then, look at that blue line. That's Pandas. Around 2015, its popularity it goes vertical. This wasn't just some new trend. It was a total game changer. It was a tool so good, so flexible, that it completely reshaped how people work with data.
So what is this thing? What exactly is Pandas? Well, the short answer is that it's a special toolkit or a package for the Python programming language, and it is absolutely packed with fast, super efficient tools for data analysis. Its main job is to give us a simple, powerful way to structure and work with data. It creates the foundation for pretty much any kind of analysis you could possibly want to do.
Honestly, you can think of it as the world's best data organizer. It can dive into messy information from all kinds of places, clean up the chaos, cleverly fill in any missing pieces, and then get everything sorted and organized perfectly. You know all that tedious, time-consuming work that has to happen before the fun analysis can start? That's often called data munching, and Pandas basically turns it into an easy, automated task.
Now, to really get what makes Pandas tick, you have to understand its most fundamental concept, something called the data frame. And the absolute best way to think about it? Just picture your go-to spreadsheet program, like Excel or Google Sheets, but then imagine giving it superpowers. That's a data frame. It's a familiar grid of rows and columns, but with the full power of programming behind it.
So here's the more official definition. It's a two-dimensional object, which is really just a fancy way of saying it has rows and columns. But the key phrase here, the real secret sauce, is highly optimized. A data frame is built from the ground up for speed and efficiency, able to handle massive data sets that would make a normal spreadsheet just freeze up and crash. And look, it seems totally familiar, right? It makes sense immediately. You've got your rows, with each one representing a different country, and you've got your columns, each holding a specific piece of information, like population or GDP. It's just clean, organized data in a table.
But here's where the superpowers come in. Forget about clicking, dragging, copying, and pasting. With Pandas, we can just tell the data frame what we want with a single, simple line of code. This command is literally just saying, hey, out of all that data you're holding, just show me the country column and the total GDP column. That's it. It's that direct.
And just like that, boom, there's a result. In a fraction of a second, we have a brand new, perfectly clean table with only the data we asked for. Now imagine doing that with a spreadsheet that has 1 million rows. By hand, it would be a nightmare. But with code, it's instant, it's perfect every time, and you can repeat it as much as you want. This is exactly what we mean by spreadsheets on steroids.
Okay, so we've established we have this amazing tool that can slice and dice data. But, so what? What's the point? How do we take this raw power and apply it to a really tough, real-world problem? Let's take this tool out of the abstract and aim it right at the heart of the financial world.
We're going to try and crack the puzzle of financial options. Now, you can think of an option as a special kind of contract that gives you the right but not the obligation to buy or sell a stock at a set price. The tricky part is that their value is always changing, influenced by all these invisible forces in the market. So the big question is, can our code help us see what's really driving their price?
All right, let's break this graph down. That orange dotted line, that's the easy part. It shows you what the option is worth the very moment it expires. Simple. But the blue line, that's the price of the option today, before it expires. And you see that gap between the blue and orange lines? That gap is the whole mystery. It's called time value. And figuring out what creates it is the name of the game.
So what we're going to do is use our Python tools to generate a bunch of these graphs. We're going to isolate the different factors that make up an option's price. It's financial DNA, so to speak. We're going to visually dissect how time, risk, and even things like interest rates can bend and shift that blue curve.
Okay, first piece of DNA right here, time. On the left, you've got an option with just 30 days of life left. See how its price curve kind of hugs that final payoff line? Now look at the right. This one has a full 6 months to go, and that gap, that time value, is way bigger. And it makes sense, right? More time means more opportunity for the stock price to make a huge move in your favor, and that opportunity has real value.
Next up, it turns out the rules of the game matter. A lot. A European option can only be cashed in on its very last day. But an American option, you can cash that in anytime you want before it expires. And that flexibility is powerful. You can see it clear as day on the graph. The blue line for the American option is always above the orange one. That extra value is literally the price of freedom, the freedom to get out early.
Now, for something that feels totally backwards, risk. Usually we think risk is a bad thing, but if you own an option, risk is your best friend. Look at how those price curves jump higher and higher as volatility or risk goes up. Why? Well, with an option, your potential profit is theoretically infinite, but your loss is capped. You can only lose what you paid for it. Some more chaos and bigger price swings just increase the chance of a massive payday for you.
And check this out, this is a really subtle one. Interest rates. Look carefully. Over on the left, for these call options, higher interest rates actually push the price up. But then look at the right, for the put options, higher rates drag the price down. It's the exact opposite effect. This is the kind of weird, hidden relationship that becomes instantly obvious when you can actually visualize the data.
So, what's the bottom line after all that? Well, after exploring all those visuals, we can actually boil down this super complex topic into a few simple rules of thumb. More risk is good, more time is generally good, and interest rates are a double-edged sword. We've used code to take complicated financial theory and turn it into a handful of straightforward, understandable principles.
And this really gets us to the bigger picture. The code we used, it wasn't just a fancy calculator. It was more like a magnifying glass. It let us zoom in on this complex financial idea, see all of its moving parts, and turn these abstract models from a textbook into something we could actually see and get a feel for.
And that's really the ultimate goal here. It's like this quote says, it's not about learning to program just for the sake of it. It's about using that skill as a tool to engineer real solutions to real problems. Whether that's figuring out the price of an option, protecting against risk, or deciding where to invest money. The code is the means to a much more important end, making smarter decisions.
Which leaves us with one final big question. We've just used this approach to look at one little corner of the financial market, but what else could we understand if we use this same lens? Think about it, modeling global supply chains, understanding climate change, seeing how information spreads through social networks. What other invisible, complex systems are out there, just waiting for us to see them in a new light?